Good morning. Good evening if you are here in California. So, according to a study by Deloitte, the average job tenure for workers aged 25 to 34, which is the demographic where most employed millennials fall, has really changed in 30 years. So, the average tenure is 3 years. So, there's a good chance that you will be changing jobs. Now, the next speaker in our Future of Technology seminar series, Ms. Anuradha Gali, has done just that. Over her impressive career, she has changed jobs many times. Now, let's hear from her. But first, she graduated with an engineering degree from Anna University in Chennai. And then she decided to pursue a master's in computer science instead of going for her IAS degree. And she started in VLSI design. Her professional career started with a position at Lucent, and then on to Manhattan Associates, Sun Microsystems, Williams Sonoma, Shutterfly, Groupon, and then finally, right now, Uber. So she is the engineering lead of the financial intelligence team at Uber. Welcome, Anu.
Thanks, Preeta. Sorry, go ahead. Were you going to say something?
Yes, I am hoping that you will share some of your insights gained during your impressive career path and also tell us a little bit about what you do at Uber. And finally, don't forget to give us your predictions on the future of technology. Are you ready?
Yep.
Over to you then.
Thank you, Preeta. Good morning, everyone, for those watching in IST time zone, and good evening for folks in Pacific time. So I'm Anu. I work at Uber, like Preeta mentioned, and I'm going to be talking about how finance intelligence powers Uber's hypergrowth. So let me figure out how to get my slide deck started. Let's start with that. Okay, I guess you can all see. So again, I go by Anu. I'm a senior manager in the finance intelligence team. So my talk is going to be a bit technical. So I'm going to be talking about deep learning and neural networks, ML models, and the engineering platform that automates it. I hope not to lose you all through it. So before we start, a little bit about myself. So I did bachelor's in India in electronics and communication, like Preeta mentioned. And at that point, I was the only person in my class who said, I'm going to do IS instead of doing master's, because that was like a big brainwave at that point of everybody doing bachelor's and coming. My fourth year, I decided to change and also apply for master's in US. And so I did my master's in computer science in University of Illinois, Chicago. And my first job was at Lucent Technologies, which was in networking. So that exposed me to data, network, and transport layers of the OSI model. And I worked up that stack. So in the last 16 years, I've worked on most of the seven layers of the OSI model. And so that's given me a lot of in-depth knowledge of just how internet works and everything. And so I've been working again for 16 plus years. And the other companies I've worked on are Sun, Yahoo, Adobe, Shutterfly, Groupon. And I know Preeta mentioned Manhattan Associates, Williams Sonoma, a few others, and finally at Uber. So if you see my career trajectory, I've worked from one company to other, starting from networking. At Sun, I worked on Ethernet routers. Yahoo, I worked on the ad platform. Adobe, I worked on like a Nike design app. Shutterfly. So from Adobe to Shutterfly is when I made the shift to move from a IC to a engineering manager, where I managed most of Shutterfly's product management teams, management teams. And then at Groupon also, I was managing some of the front-end consumer-facing teams. So I've been working with e-commerce and consumer-facing teams for some time. And as big data and machine learning is getting very popular and everybody's talking about AI, I was like, I think it's a great time to be in it. and where else can you work at the scale of Uber and at the cutting edge, bleeding edge that Uber is doing. So when Uber called and there was a fit, I jumped onto that wagon, and so I've been working with Uber for the last year plus. So going across, so the journey continues. So one of the things somebody told me a long time back is always have an exit strategy when you take a job, right? So that always made me look out for opportunities, both internal and external, and to keep challenging myself and to keep taking harder problems with each step. I also like to study, whether it's higher education or taking courses through Coursera. It keeps me grounded and always have a beginner's mindset. So moving on to stuff at Uber. So Uber is one of the growing group of Silicon Valley companies that uses ML to guide their business strategy and finance decisions. And our objective is to supercharge decision making with objective, intelligent, and automated financial insights. Some of the business facts about Uber. Uber operates in 700 plus ride sharing cities, 300 plus Uber Eats cities. We have about 37 billion gross bookings. This has changed. This is one of the older numbers. This is excluding Uber Eats, which is growing at a phenomenal rate right now. We have about 75 million active riders, 3 million active drivers, and we do about 15 million trips a day. So our goal is to enable intelligent models to make data-driven financial decisions faster and more accurate. So we'll go through the planning process. So what I'm going to go, the whole my slide deck about what I do at Uber is we do strategic long-term forecasting, optimization, budgeting, and LTV predictions for the whole of Uber, rideshare, and Eats business. So I'm going to go through the whole process and also cover a little bit about the ML models and the engineering platform that we use. So everything starts off with CEO, CFO, or any C-level person coming up with the targets for the country or region. Example, we'd like to double trips in India next year. Then our model will calculate what's the spend in each region and the trips we can get from the spend, along with the gross bookings, which is the number of trips into average fare is the gross bookings, and also the revenue from it. And then we display these numbers to the GMs who run the different regions, and they either accept or update these numbers. The platform will suggest, okay, so the next thing is so they're also able to play around with these numbers. So they can increase the number of acquisition spend. They'll see if the trips go up, and so they can, the target will be where they are comfortable with. So the next step is the budgeting. So this is the phase when we open up our tool for the executive leaders or any org leader who is responsible for a budget. So the adjustments, they make any adjustments to the budget. So our tool will first look at all of our top line growth for the year and the budget we allocated for each of the departments last year. And based on that, we'll come up with some recommendations for this year. And the leaders will adjust their budget as needed, and they have to provide justification if they up it. So this whole process is done in 4 phases, and as it is heavy, we do it only twice a year. But some of the adjustments and the shorter term forecast happen more regularly. The first 4 phases will give us 12 data points, 1 per month. And then, so these 1 per month data points will have to get spread out into weekly and hourly by our operational teams and few other teams working at Uber, who help take the monthly forecast and come into hourly, weekly forecast. So our optimization process is also very useful for this. They'll vary the spend based on how many drivers we can get by spending X dollars in maybe example Delhi for this week. This is a continuous process that keeps evolving. And the next step is we have a bi-weekly pulse check, which is a comparison of what we predicted, budgeted to our actuals in every region. We gather insights from this process improve our models based on the learnings. Theoretically, it can be a continuous process, but we continue the optimization of budget. And the next is once we analyze it, we gather insights, whether we are, if we do not meet the targets, why did we not meet the targets? And how can we incorporate this into our models? And then again, this is a continuous process. So as we improve the models, we go through this again. So let's look into how we do forecasting. So our forecasting from the previous process, the first stage, which is trip forecasting, we take the historical trips, add the acquisition spend, adjust any levers, which you see here, and apply a time series model to predict the long-term forecast. And we use a cohort model to put the riders, drivers, and eaters in cohorts on the platform based on the month of joining and the first trip. It's a functional formula to represent the trips, which is a multiple of the rider driver's first trips, the percentage of retention rate of the existing users, and trips taken by the active users. And so at the end, we create this something called a black box model, which is an ensemble of these classical and Bayesian time series model. This ensemble weights are calculated by individual model performance on multiple backtesting period. What backtesting is so we'll forecast based on some of the models, and when this is out and we get the right targets, we'll make sure which of these models were actually more correct. And based on this is when we create the ensemble weights, and we create this ensemble models based on which models perform better, and we'll create this combination of models. And we combine offline and online predictions for it. Our entire model is an ensemble of ensembles. So this, in addition, okay. So this is how our forecasting model looks like. So on the left, we see all of these features. It's all the trip transactions, the marketing spend, and the first-time rider-driver sign-up. They all form in this iterative process. Over here, the cost curve model is the amount of spend versus how many trips we'll get. And it's an S-curve. So after a point, you'll see that we do not, there is a diminishing ROI on the amount of spend you do. And so this model is present for every city. And so we have 700 models come for each. Again, we have that many number of models, and we predict it on the city level because every city, there is a different variation of it. So we'll go on to the next stage of our process, which is optimization. So when we do our initial forecasting from the previous slide, we are at the region level. The problem we try to solve at a region, how can we best allocate the acquisition budget between the rider-driver paid with driver referral between months across PUs? The results are targets for the GMs and the ops teams. Whereas on the short-term optimization stage, we try to optimize within the given planning unit. Again, a planning unit is actually a collection of cities. Sometimes a big city, like San Francisco, is its own planning unit, versus sometimes a collection of cities will form a planning unit, which is the lowest denominator to which we allocate budget to. So the short-term forecasting stage, we try to optimize within these planning units and how we allocate the total acquisition incentives budget between incentives, incentive spends, paid versus driver referrals, between weeks, each week across all of our channels. So results from these are operationalized as immediate decisions. So this spend decisions actually go into our GMs and ops teams, and this is how they spend for each of the channel across each of this incentive, paid, and referral budget. So this is an addition to one of the previous slides we saw. Our total spend comes from the top line, right? So our total spend The amount of trips and gross bookings and revenue we have comes from the us using the time series model and a long-term forecasting. To that, we add a user level model, which pretty much gives us, we calculate the driver incentives and the driver promotions, which give us the short term rolling forecasts or the budgets that we can spend each month across the channels and markets. And again, each of these are levers, so we can sort of move the levers or adjust different levers to see how it affects our final revenue and our trip growth. So this is a snapshot or a view of how our UI looks. After we do the initial predictions, this is actually how our online predictions can work. So this is a tool we open up for some of the leaders like GMs who run the cities, who can adjust the incentives and see if the engagement of the users can change or if the trips of those users are changing. We also show which subset of users we should focus on to meet our goal. So over here, you can see that focusing on the highly engaged users is actually going to give us more bang for the buck. So combining insights like these can help Uber adjust its budget in the short term. Okay. So this is the model overview, which has 3 stages. So this is like the first stage, this is the second stage, and this is the third stage. So this again is a neural network deep learning model, and it's a collection of models that we run. So the first one is calculating how many drivers riders sign up can we achieve by moving budget between paid organic, referral, and in the rider case, also promotions. And each of these will give a cost curve. This is the cost curve that I mentioned, which is for the amount of spend, how many trips will you get? So after a point, if you see, it starts tipping off, right? So you can increase the spend, but you're not going to increase the number of trips after it, there's a diminishing return. So the portion of the and also the portion of the users who sign up do not take the first trip. So they are called the stale users, and we predict this per channel. The second stage is the user level model, which is a function of vector of features, trips, and the incentive spend. We run this per city, use driver's last week trip as a baseline. So as this is a very complex model, the best model to run this is the LSTM, which is long-term, short-term model with zero inflated Poisson loss. So that's my, so I'll go in a little bit to the stage 2, so which is the LSTM. So this is another neural net model, as I mentioned before. And over here, the FT is the behavior features at a time. Feature embeddings per driver. LSTM2 input is the feature embeddings and future incentives, which is the future incentives, which you see here, T plus 1, T plus 2, and T plus N are the incentives. The output is the updated feature embeddings at a given forecasted period. Lambda and pi over here are the parameters of the zero inflated Poisson distribution per driver per week. FC over here is fully connected layer to map the feature embeddings to the 2 outputs. Over here, the Y1 to Y2, Yn are the final predictions as expected by the zero inflated Poisson. We do have an offline training and an online prediction portion for this pillar too, which enables our users to modify the levers to see how it'll change the final predictions. So we can change the incentive spends here, and that will change the final predictions. And so we can see how we can change the spend between our incentives, promotions, paid, and organic to see if there is a change. And so coming to the lifetime value. So the lifetime value of a customer is at the core the contribution the users make to Uber. This is an important metric which is used to drive efficiency in marketing and incentive spend. We use it as a KPI to measure product enhancements. So we'll go on. Okay. LTV is an estimate of the lifetime contribution of each user, driver, rider, eater, in order to drive efficiency in marketing and incentive spend. And we also use it as a KPI to inform product improvements. So we all of the product improvements or features that Uber does, we go and measure the LTV value after the product is in the market for some time to see if it increased the value of the riders, drivers, or eaters using it, to see how good our product is performed. So this is tech and model overview. We use gradient boosting trees for predicted LTV, which is an ML technique for regression and classification problems. We also use gamma gamma BG NYD model, it stands for beta geometric negative binomial model, for calculating the rolling LTV for the next 2 years. Actually, this is popularly known as BTYD model, which is buy till you die model, which means that the users who are engaged are supposed to be engaging with you or buying from you until they churn. So this again, both of these models are an iterative model, similar to some of the other models we saw, where the predictions of one iteration are input to another, and you have a final output after n iterations. So the engineering platform to automate this is based out of a PySpark, Apache PySpark ecosystem. We use Spark streaming to process the data, PySpark to run the models. So okay, so let's have a quick look about the platform. So this is the platform that brings it all together. At the foundation, it's a data platform, which consists of data ingestion pipelines. So we ingest data from dozens of different data sources. We run ETL pipelines and processes to come up with the metrics. The metric store has a collection of all the metrics that we need, not only to power all of these ML platforms and UI, but it also serves as a tool which can be something that Uber can leverage when for reporting to the street or to investors. Then on top of that, we have the ML platform. We have 2 levels of ML platform: the offline training and the online predictions. So the first layer contains of the forecasting models, the optimization models, the LTV models, and all of them are used for offline training. Then we have our scenario management service. And the scenario management service consists of a model orchestrator, a metrics computation service, and which consists of, and also an APIs that can get leveraged by the UI that we have created. We also integrate with several different other platforms in Uber, which take our input, because ours is the long-term metrics, and they predict a lot of short-term data from that. The UI layer on top lets the users view all the predictions, modify the scenarios, rerun the models, and see how it affects the trips and revenue. We have a security application that provides various levels of security to all finance users. And we also have analytics that is used for displaying all the P&L, the actuals, the trips, the budget that we have spent versus the targets. So this is used for a lot of reporting by all teams right now. And if you see, I think this, so this is a diagram that sort of brings everything together. The planning, which is a combination of forecasting our trip growth, and budgeting, which is all of our bottom line costs. Then we do the lifetime value of the riders, drivers, and eaters we have acquired. And they both flow into this optimization module, which determines how we'll optimize our spend across each of these. So this is our data platform. So this I'm actually it's very close to my heart. This is the first team I led at Uber. And so at the core, this is, we ingest data into through several different data sources. And we create this metric store, and we also have a secure hive. So big data technologies are not inherently secure. So Uber created this security around Hadoop and Hive layer. And we have a policy store. And as we saw, this security layer actually creates the security policy store around this. And we have data aggregations at every layer. And we have a visualization layer. Okay. So bringing this together for the Future of Technology series. My team at Uber is at the bleeding edge of continuously planning, budgeting, and optimizing for Uber's growth in every market. So I'm just going to go back to this slide. We are planning on open sourcing this platform for any company to use. We should be able to plug in into your data. We are also open sourcing some of our data platform because of the way we have created our security and other analytics on top of it. This will help businesses optimize their spend across every city segment and go after the right customer. So we looked at a lot of models. So you can either bring your own models, or you can use some of the models that we will provide as a part of the platform. So as our footprint grows, we are so this is on all of the outsourcing of this technology to outside, which we hope to do sometime next year if everything goes well. But as our footprint, as the Uber's footprint is going, right, we are learning about urban planning and would like to collaborate with local governments and municipals to plan roads better, facilitate better modes of transportation. Some of the near-term initiatives we're working on are drones for faster food delivery. I don't know how many of you have seen, but we have a pilot of a drone delivering food, which I think is very exciting, because that as we are delivering food across in the cities, there's a lot of it takes time. So how do we deliver food fast? And so that's something we're trying out. Uber Elevate is a air transportation that can fly people between suburbs or from suburbs to the city. And we are hoping to make it economical, and it's a quicker mode of transportation than just by road. The long-term initiative that Uber is working on is the autonomous cars. It's an exciting time to be working on AI as we look into disrupting a number of industries around us. As most of you are students and looking forward to the next step, I'll leave you all with this. Have a goal, short term or long term. Build a strategy to achieve it and fail fast. Keep refining your goals. Your goals can change, right? I actually go through my goals, my vision and mission every year to make sure that it's still aligned. And when things change, for example, I talked about AI and my willingness to learn on it, it's okay for you to either do a lateral move or step down in order to get the technology, because the technology space is growing a lot. Or sometimes I would also just take a course or go to school to get that experience. So definitely have a goal, both short term and long term. Build a strategy to achieve it. Fail fast. Keep refining your goals. You only fail when you stop trying. There's always interesting things to learn and grow. It's not the destination, it's a journey that makes it fun and worthwhile. So with that, I think, let me just see. Okay.
That's wonderful.
So I know I finished fast. I can take any questions, Preeta, if there are any questions.
We actually have a really quick shout out to the students from IIIT Dharwad that have been communicating on this channel with us. there was one question that I had, which let me just read that out for you. It has to do with what you've learned from your many positions. So a student asks, what is the best advice you have for when you
I think I lost you.
did you lose
I
me?
lost you, Preeta. Can you repeat it, please?
Sure, sure. They want to know if you have any advice.
I lost you again.
Can you hear me?
So I think I feel like, are you able to hear me? Because I get stuck, or not. I don't get stuck. I feel like you're getting stuck, but I'm not sure. So what was the question? Just tell me the question alone.
Again, not a problem.
Mm.
So there's a student here who wants to know if you have any advice on how best to change jobs in during their career, like you've done. Do you have any advice for them?
So I have always, like I said, right? I think it's when you take up your first job, to think about what you're going to learn from this job, right? So it's to challenge yourself, is to make sure that you're learning what you want to learn. So there will be some jobs that I've been in where after a point I'm not learning anything new. So that's something that you want to ask yourself, as in, is this helping me? Am I challenging me enough? And something that I think about is am I being uncomfortable? I think that's the biggest thing. If you have to be a bit uncomfortable, if you're not a bit uncomfortable, you're not learning. And to be frank, I think at Uber, because I made the shift to go from working on mobile web, backend technologies to into AI, machine learning stuff, it made me very uncomfortable. It still is. I learned a lot about statistical and math models and everything in school. And after that, it's taken a long time. And now I see all of these big formulas. It's hard. It's crazy. But challenging yourself, I think having that growth mindset and learning is key. And if you're not, the best is to look out. The best is to think about, hey, what is the skill that I want to learn, right? And what is my next role that's going to help me learn the skill? So it's not necessarily the company, but I would go for the skill, because when you've learned enough skills, I think the right company would come and approach you. We have heard this all a lot, wherein somebody is doing this awesome things, publishing blogs and doing these experiments in AI. And there are times when Google approaches them and says, hey, I want you to come and work for me. So I think it really is going for your passion and really doing it. And that's going to help you, make you more attractive for the companies that you might want one day.
That sounds awesome. It's really good advice, and it gives people, a sense of how you were motivated to move from one position to another. And I think we really appreciate that. I personally also enjoyed hearing about the drones that are going to be dropping my dinner outside my house, because I think that would just take the load out of so many things. But once again, Anu, thank you again, and I really appreciate you taking the time to put together this talk for us and give us this insight into the future. So thank you again.
Thank you.